This Week in Science and Education is brought to you in part by the University of Western Ontario, www.uwo.ca. We thank them for their support. This Week in Science and Education is also brought to you by Laurentian University. Check out Laurentian at laurentian.ca. We thank them for their support.
Hey everybody, it's time for This Week in Science and Education, the show that talks all about the latest and greatest science marvels from around the world, and specifically today from Sudbury, Ontario. Joining us is a friend of our good friend, Dr. Thomas Merritt, and Thomas is going to introduce him shortly. But before we get to him, let's say hi again to our co-hosts that we haven't seen in at least 2 months. I think they've been on sabbatical somewhere around the world, I'm not sure, but there's Colin Jagoe from Kawartha, the Pine Ridge District School Board. Hey, Colin.
Hello, hello. How are we?
Good to see you again, and of course Dr. Thomas Merritt from Laurentian University. How you doing, Thomas?
Very well, it's nice to be back. With me is Dr. David Lesbarreres from Department of Biology. Still? No?
Still.
Yeah, okay. At Laurentian University. David is a colleague. We've actually got one grant together. Mm-hmm. One paper that won't die that we've been resubmitting. And we've been working together for the 5 years that I've been here. We're lucky enough to get David to come in and talk to us this afternoon.
Fantastic. Well, David, thanks very much for taking the time to join us, and we're looking forward to learning a little bit more about your research. So why don't you start things off just by telling us a little bit about who you are and what you do.
I'm a Francophone faculty that joined the Department of Biology about 7 years ago here at Laurentian, and I came to work mainly on amphibian ecology and population genetics. So that had led to different projects, either on ecology of amphibian population in Northern Ontario, mainly related to road ecology. So Northern Ontario is not as dramatic as you guys in the south as far as roads, but we have our fair share of infrastructure that impact frog populations. And then the other side of my research is more specifically looking at disease. So there's 2 main diseases in the world that are affecting amphibians. One is a fungus known chytrid. It's usually making the headlines of a lot of newspapers recently. And the other one is a virus, a bit less known, called ranavirus, but is also lethal to a lot of populations of frogs worldwide.
So one of the things that, one of the reasons I wanted David to come in and talk to us this afternoon is the work that you haven't done on the pathogens and sort of bigger picture that a lot of teachers may have been aware of, maybe talking to their classes about already with global amphibian decline. And one of the nice things about David's research is you're working in a specific area, but you've got an implication on a larger picture. But before we talk about that, just for a second, one of the things that we've talked about often with the guests that we've had on the show are collaborations and working together. And the reason I thought of having David in this afternoon was because we have an interesting collaboration, and we've been working together for the 5 years that I've been here. As we've talked about in the past, I'm pretty much a model systems geneticist. I don't get out in the wild all that often, whereas David's background is much more applied. But we've been able to work together on a couple of different projects, and we've co-supervised students in the past. So although we have different interests, none of my work touches on pathogens or amphibians, that work is actually complemented really well, and the basic genetics that I do is tied into the more applied work that David has. But David, maybe you could tell us a little bit about when somebody talks about global decline in amphibians, what is that? Why is it important? And then a little bit about what your research is telling us about that.
The amphibians worldwide are declining at a pace that's way faster than any other group. So the animal kingdom is mammals, amphibians, reptiles, birds, and fish. Amphibians are taking the bigger hit at the moment. They are, I think, 32% of the species that are endangered one way or another, and another 42% are close to be and are threatened at the moment. So there's really a lot more impact on those species than there are on birds, on mammals, even though probably they are not as emblematic as the panda and the polar bear and other type of species. Various reasons for these declines, one of them being that amphibians, as their name coin, are both on land and in water. So whatever impact on the ecosystem, they're going to be double impacted by those. Pollution in the water, pollution on land. agriculture has a big impact on those. There was lots of work in the 80s and 90s on atrazine in the US. Lots of frogs having 5 legs, 6 legs, or being only males due to hormone dysfunction from that pollutants. So that's one of them. The site that I'm looking at that's been only sort of not discovered but really investigated in the late 90s was the wildlife disease. We heard about, again, more sort of emblematic disease for the avian flu for birds or the mad cow disease for cows and sheep and mammals in general. Amphibians did not get a lot of spotlight, but the fungus that has been studied mostly in the last 15 years has decimated population. There is a Panama toad that totally disappeared because of that fungus, and it's all over the world. We are not sure yet whether it was present in the past and just came up because of different pressure on the ecosystem. Maybe global warming has raised the temperature of the environment so that the chytrid is more lethal now on frogs, or because of the widespread trade of amphibians. Lots of species are traded worldwide, some for research. The xenopus, the African claw frog, is used in research and teaching. And others, like Dendropathy, these dark poison frogs from the Amazonian forest that are really shiny. You find them in every pet store in the world. Well, that's one way to spread disease all over the place.
And this is the fungus that you're talking about?
Yeah.
Okay.
David, I'm just going to have you move about a foot to your left, if you don't mind. Your face is kind of getting off camera, and for those of our listeners that are watching my video, we want to give them the satisfaction of seeing your complete body. There you go. That's perfect. Quick layman's question for you, and I'm not trying to be cheeky with this question, but give us the why do we care if the amphibian population is decreasing and decreasing so rapidly? For those younger students out there, why is this important to us?
Well, like every species, they have a reason to be here. They are adapted to what we have today, so they are one piece of the puzzle. So one can say that removing one piece is not a big problem when you have 1 million species on the planet. But I think frogs have a key part of that puzzle, again, because they are the interface between land and water. They are really important in the control of mosquitoes and other bugs. Removing those from the story might lead to an increase in those population of insects. And with mosquitoes comes a lot of disease too that would not be controlled if frogs were absent. So that's sort of their role as a predator. But they're also a prey for other higher species, mustelids like mink, weasel, some birds also. So if you remove that resource for those species, then you get a sort of a cascading effect on higher level species that are going to disappear because they don't have anything to eat anymore. So like every other piece of the puzzle in that sort of trophic level, the resource level from bottom to top or top to bottom, removing one always have a bigger effect than we can imagine just looking at one species specifically.
Yeah. I think that's a good explanation, a good way to talk about that. I'm sure Colin wants to jump in. Colin, I'm sure that's one of the issues that is being taught today that's curriculum relevant is this whole circle of life type of idea.
Well, absolutely, and I mean, in many science courses, ecological studies science courses, grade 10 science, grade 9 science, it's ecological like food webs and biospheres and human impacts on the biosphere. All that is in place, and you talked about frogs being an important species because they spend part of their lives in water, part of their lives in land, so no matter where pollution is, it sometimes has a way to impact frogs. And I know one of the things that is very often taught in high schools, when I'm teaching in high schools, is that the frogs are like the canary in the coal mine. They're an indicator of potential problems down the line because of their sensitivity to certain things, and they're very often the first species to decline in an area with something like either pathogen or pollution, like you mentioned. Now, is that a fair assessment? Is that something that is a fair thing to teach in high schools, that when something starts going wrong with the frogs, it's possibly then an indication of a bigger problem coming along?
It's a fair statement, but I would be, and I guess that's a statement I would have made teaching 10 years ago. I think now I start to revise that because although I don't have a long life experience working on frogs yet, I've noticed that these species, these populations can adapt a lot, and we always have designed ponds for amphibians, and we always think, oh, they are really specific, they need that type of shoreline, they need that pH for the water, they are really specific, right. And if you mess up something, they're going to disappear. That's not really true. I find a lot of places where I don't expect to find frogs, and they are there. We have, so in northern Ontario, there is mining industry in Sudbury, and some of the tailing ponds where they still use that as a buffer for their industry, pH being very low, and we have reproduction of leopard frogs currently every year. There's another paper mill industry about 200 kilometers west from here. Same thing. There's a lot of frogs that are in there. So I think because of the way evolution works, they need to adapt. And the statement we could make years ago that they are really sensitive is still true. However, we can find them in places that are not so convenient and maybe ideal for those populations. So making them the one species to look as an indicator might not be totally true. I think there are other species that are a lot more sensitive. Maybe damselfly, for instance, seems to be a more important indicator in terms of water wetland quality than frogs.
But let me just jump in. If given what you're saying that they're more adaptable than we would have guessed,
yep.
In cases where we actually see them responding, then that's an even stronger indicator that we have pushed the environment farther than we should.
Yeah, that's true.
So that if you do see a response in the amphibian populations, then things are more dire than they're not so sensitive that a small perturbation, a small change is going to destroy the population, but that they will respond.
They will.
And I think the one important thing to get across to students is they are responding, and we are seeing global changes in numbers, as you said, the number of endangered and threatened species. So given that threat, and given what you're finding that they're more robust than we would have guessed, when we do see an indication, it's evidence that there is something drastically wrong with the environment.
I think what I want to maybe mention to the student is that when you think about an indicator species, students are going to tend to think, okay, it's there or it's not there. And I think the response of the amphibians is a bit more subtle than that. There's going to be less species within a community. We might find only one species or two, less individuals, or these individuals are going to have different life history traits. They're going to mature earlier because the water is less present in the pond. The ponds are drying out in the summer. So their tadpoles are going to metamorphose earlier. So that's the type of response you can look for in terms of frogs responding to the environment, not so much presence, absence.
David, we need to take a quick break, but before we do, I want to tell you a funny story. So my wife is our local frog saver, and so over the summertime, I would periodically see her wandering around the backyard of our house, and she has these plastic gloves on. And I finally asked her one day, "What are you doing, dear? Why do you need those gloves, and why are you wandering around and making funny gestures?" And she was rescuing frogs out of our window wells, who keep jumping in there all day long, and they're having little babies, and they're little tiny suckers like this, you know, and there's hundreds of them. So in our neck of the woods, I don't think that we're in too much danger of losing our frog population. But anyways, you have a champion there within my own house. We're going to take a quick break, but and thank our sponsors. When we come back, David, I'd like you to tell us how children and how students can help save the frog population. So have a thought about that, and we'll take a quick break now and thank our sponsors.
This Week in Science and Education is brought to you by Sheridan Institute of Technology and Advanced Learning. At Sheridan, students shine brighter. Check out sheridanc.on.ca.
Okay, we're back on This Week in Science and Education, and we're learning all about the declining frog population and what the troubles are associated with that. And David, before we went to break, I asked you to think about some ways that some students can think of how to help frogs in their areas. Do you have some ideas surrounding that?
Well, when I looked at disease, for instance, I think one of the modifications that's been put forward, at least in Ontario, and students and kids have been a big part of that, is as a tradition here, people use frogs as a bait going fishing. And it doesn't matter where you would catch the frog. You could take it to a different pond, a different lake to go fishing. That has probably been a cause of the widespread of disease. So now it's been regulated that you can't take frog from one pond to the next. You can still use it as a bait, but you have to stay within one pond so you don't spread any disease. So as a pet or as a fishing hobby, one of the recommendations is don't move population around. Leave them where they are so you don't spread the disease.
So I think that, I've noticed it in at boat ramps. There's signs for, clean your boat.
Yeah.
And this is a big deal in Northern Ontario, trying to spread or to reduce the spread of invasive plants. So with the fungus, we're looking at the same kind of situation.
Yeah, that's valid for invasive plants, zebra mussels on boats, and then disease on frogs. Yeah. And we have probably been part of that problem, not knowing the consequences when researchers were going from place to place and not necessarily cleaning their gloves, their nets, and their boots. It's likely that some population have been infected by disease due to researchers and people going from one place to the next. So I think it's really something we should look now, is to be careful when we go, even when you go camping. It doesn't take much to just clean your gears, clean your boots before you go camping to the next site.
David, you were talking a little bit earlier about one of the emerging infectious diseases, rhinovirus. I was wondering how exactly does that spread from frog to frog or population to population, and does it spread from one particular species of frog to another species of frog? How widespread is this viral spread, if you will?
This virus? The virus is a lot less known than the chytrid. People have looked at it only for a few years now. It's been discovered in the 60s, but it was not sort of a problem until maybe 5-10 years ago. We don't know much about transmission. There's definitely a potential for maternal transfer, so from the parents to the eggs, and then therefore the embryos. The eggs themselves, when they are laid in a pond, they seem to be protected somewhat by their jelly. So infection doesn't really happen at the egg stage, more likely at the adult stage, like every other viral disease by contact. A virus, by nature, cannot live outside of a host. So they have to be inside the adult, the embryo, or the juvenile. So the transfer seems to be a lot sort of what we call vertical transfer, from parents to offspring, and possibly horizontal from one individual to another. And we are still looking at what part of the immune system is defending. Why would the tadpoles be the more that are the ones that are most affected? When we do experiments, there's a lot of adults that can carry the disease, don't show symptoms, and maybe recover from the disease. When you infect tadpoles, they seem a lot more fragile, possibly because their immune system at that stage is really weak and in process of building that. And then we have also species that are what we call reservoirs. The bullfrog, an invasive species in some part of Canada, doesn't have any problem with the disease. So, and because it's invading a lot of environment, it was not present, for instance, on Victoria in Vancouver Island. It's been introduced there, and with that introduction came the disease that whipped a lot of population of frogs, but not the bullfrog. So now the bullfrog is established. Lots of other population of frogs have suffered from it and have disappeared, and then the bullfrog is still there. So that's one way also to spread the disease with a reservoir species.
So just to be clear, the bullfrogs are infected with the virus, but they're asymptomatic. Right, so they're not showing any characteristics of the disease. So with both the virus and the fungus, are either of those pathogens moving out of amphibians? I mean, are these amphibian-specific pathogens, or?
Oh, no. The virus, for instance, can affect that family of virus. There's different strains with different groups, but that family of virus, you find it in all the ectotherms, cold vertebrates, so reptiles, fish, and amphibians.
Okay.
The chytrid is really specific to amphibians. It's mainly on the sort of the skin. It's like what you call the athlete fungus between your toes. Yeah. So that's the same type of fungus that goes into the layers of the skin and disrupt the the balance of the ions and the equilibrium of ions. And frogs seems to die of a heart attack because there is an unbalance of their system.
Dies of a what, sorry?
A heart attack?
Heart attack.
Yes.
That is a bad case of athlete's foot. That
yeah.
Heart attack from athlete's foot. That right there defines.
But we recently discovered some frogs have peptides, proteins on their skin that protect them from the fungus. So they respond by an overproduction of those peptides that sort of clean and protect the frog from infection, and they can shed the spore of the chytrid and not being infected.
So it's sort of the tenactin of the protein world. Yeah.
You know, one of the biggest problems is, David, is this guy that's co-hosting with us. He purchases 10,000 frogs a year for kids to dissect in the Kawartha Pine Ridge Sport there.
Yeah, that's a little bit different though. It's not quite the same as going out in the ponds and taking them out. I've actually got two things that have sort of occurred to me as we've been talking that I want to ask you about. The first one has to do, you mentioned about evolution and how adaptable populations are, and you're starting to find them in strange places. And this is your funny story as well, Kevin. I got thinking about being a kid and playing around in ponds and finding masses and masses of frog eggs, and then watching them grow into tadpoles. And of course, not all of those become adults. Only a very small number of them actually make it to adulthood. Are frogs, because of that, more suited to faster evolution and faster adaptation because of some of these pressures? Or is there something else going on there?
Well, it'd be interesting to Thomas to jump in with his Drosophila that just produce eggs a lot and also at a faster pace.
Sure.
Vertebrates, so higher class animals, do respond a lot slower to evolution. But not only you have to look the pressure from the environment to create sort of a scenario for evolution to take place, but you also have to look at the internal machinery of the animal, how many mutation can accumulate and on a specific species, and how they will be either conserved because adapted or not be conserved if they are lethal. So I don't think it's easy to make a conclusion that frogs will react because of their life history and because of the fact that they produce a lot of eggs. I mean, there's a lot of animals out there that have the same reproductive strategies. So I don't know if we can make the assumption that because of their reproduction, they will be responding faster.
So David's entirely correct, but if you were to look at the extremes, the extremes would hold up what you're saying.
Yeah.
So
elephants.
Elephants, and elephants are even more extreme. I was thinking if you compare, so we interviewed Jackie Litzkis, my wife, who's here and also in David's department. She works primarily on turtles, and when you're working on turtles, a big clutch of eggs is 20, right? And the species that she works primarily with, they have clutches of eggs that are as small as 2 or 3 clutches of eggs a year, and they take about 15 years to get to reproductive maturity. So when we look at species that are responding to changes in the environment, species like turtles respond very slowly. There's very little genetic variation, and it takes a long time for the next generation to get there. And so they tend to go extinct rather than adapt through time. Now that said, turtles have been around essentially longer than almost every other vertebrate. So there are ways that they have evolved through time, but they do not evolve quickly, and that's where a lot of the human pressures have been an issue. So in general, something like that, an elephant which takes 30 years to go to maturity or something ridiculous, they evolve very slowly. And if you look at a mouse, which has a number of litters per year, or a frog, which might have 1 clutch of eggs a year?
1,000, most likely one of about 1,000, 2,000 eggs.
Yeah, and so the numbers are there, although it's a single clutch. So it's a yearly reproductive, but you've got a lot of individuals that are there, as opposed to things like my fruit flies, where you've got in a given summer,
They're not in danger, are they?
No, they're in danger of taking over my house at the moment. But you're going to get 10 generations in a summer, and a generation's going to have maybe a single female can produce 300 to 400 offspring. So the flies do respond more quickly than frogs, frogs probably respond more quickly than turtles and elephants. So, it depends on the comparison column that you're trying to make.
Yeah.
And at the extremes, you do see differences that reflect the lifespan. But then, I mean, one of the interesting things that David brings up is it's not just the number of generations. And the speed at which a species will potentially adapt to something is not as simple as saying, if you produce a lot of generations, you will adapt.
Right.
But species that produce a lot of generations tend to adapt more quickly. And bacteria and virus are the example of that.
Yes.
All right, bacterial antibiotic resistance. The reason that bacteria become antibiotic resistant is because you're producing millions of bacteria at a given time. And so there's a lot of diversity out there to be selected for the rare individuals that are resistant to a given antibiotic.
Sure.
Well, this has been a fascinating discussion today, David. I'm so glad Thomas was able to twist your arm and have you appear on the show. Thank you for your time. I want to give you a last opportunity to maybe provide the students and the teachers that are listening with one last message of anything that you think is important for them to take home with them.
Well, I guess as an ecologist, yes, I work on frogs, and frogs are disappearing, and it's important to save them as part of a general biodiversity. But I think what I still learn is going out there. I learn a lot by just going in my backyard, and I look at frogs, but I could look at birds and insects. And I think our job as an ecologist or as a biologist in general is so interesting, and it goes back to the school when I started to do that. So I think if you can, and I'm sure Colin does that well, if you can strive those students to look out there, there's a lot of questions to be answered and a lifetime opportunity for entertainment.
Wonderful.
Dr. David Lesbarreres has been our guest today. Thanks very much, everybody, for tuning in and watching, and thanks to my co-hosts as well. We'll see you same time again next week. Take care, everybody.
Bye. Thanks a lot.